If your business is online, you're a global business. It's just that simple. But that creates a massive problem, right? Your data has to be everywhere, all at once, for everyone, and it has to be instant and secure. The catch? Data has to physically live somewhere, and that's where the real headache begins. Okay, let's get into it. So here's the game plan for this explainer. We're going to really unpack this whole global data dilemma. We'll kick things off with the absolute core strategy for splitting up data, something called sharding. From there, we'll see how you can place that data with purpose, how you keep the lights on when things inevitably fail, and of course, how you keep it all secure. And finally, we'll look at the big, tough choices that the architects behind these systems have to make.
All right, so let's set the stage here. We need to frame the central problem we're really trying to solve, because serving a global audience, it's not just about, translating your website into a few different languages. It's a deep, fundamental data architecture challenge. I want you to just think about this for a second. Where is your data right now? Is it in the server park down the road? Or is it halfway across the planet? And who decides who gets to look at it? These are not just geeky technical questions. They have huge, real-world consequences.
Every single modern data system is in this constant tug-of-war between four huge demands. You've got speed, right? Because let's be honest, nobody waits for a loading screen anymore. You've got security, because the threats are relentless. Then there's compliance, with this crazy growing web of international laws. And on top of all that, you have the sheer scale of trying to handle millions, maybe billions of transactions. Nailing this balancing act? Well, that's the heart of the whole dilemma.
So how on earth do you even begin to solve this? Well, the first, and I mean the most foundational step, is a strategy called sharding. And believe me, this is the architectural key that unlocks absolutely everything else.
To put it really simply, sharding just means you stop trying to cram everything into one giant monster database. It's just not going to work. Instead, you break it up into smaller, much more manageable, independent pieces. We call these shards. Think of it like this. Instead of having one massive central library for the whole country, you create a network of smaller, specialized local branches. It's just way more efficient.
So how does this actually work in practice? Well, when you make a request to a website, it carries a little piece of information with it, called a sharding key. Could be your user ID, your region, something like that. Now, as you can see in this diagram, there's a component that acts like a traffic cop. It's called a shard director. It just glances at that key and boom, instantly routes your request to the exact shard where your data lives. It is incredibly fast and totally essential for hitting that massive scale we talked about.
Okay, so you've split your data into all these handy little shards. The next big question is, where do you actually put them? And this isn't random. Oh no, this is a very deliberate, very important strategy.
The critical idea to get your head around here is that data has a passport. And there are two huge reasons to place it carefully. First up, compliance. Laws like Europe's GDPR flat out require that European user data stays physically inside Europe, no exceptions. And second, plain old physics. The shorter the distance data has to travel, the faster the experience is for the user. We call that low latency. So it's a total win-win.
And this is how it's done. It's pretty clever. First, the system uses something called geospatial intelligence, which is just a fancy way of saying it figures out where you are in the world from your connection. Second, it tags your data with a regional key, let's say Europe. From that moment on, every single time you interact with the service, your requests are automatically sent to the database shard that's physically located in your part of the world.
Okay, so we've got a handle on speed and compliance. That's great. But what happens when something breaks? And I mean really breaks. What if an entire data center just goes dark? Well, that brings us to our next pillar, high availability.
Now, this diagram might look a little complicated, but the idea is actually simple and frankly brilliant. You don't just have one set of shards. No way. You create a perfect mirror image, a replica in a completely different part of the world, and the data is constantly kept in sync between them. So if your main data center in, say, Region 1 suddenly fails, the system automatically, instantly reroutes all the traffic to the healthy Region 2. For the user, they literally never notice a thing. The service just keeps on running.
And the impact of doing this it's just massive. Let's put some numbers on it. In a traditional system, one big database in one location, if that site fails, your application is completely dead in the water, 100% down. But in a sharded system that's spread across, say, 5 global regions, if one of those regions fails, you only lose the users whose data was in that region. A full 80% of your application just keeps on trucking, serving users without a single interruption. It's a game changer.
So our system is fast, it's compliant, it's resilient. But is it safe? That is the final and maybe most important piece of the puzzle, protecting the actual data from being lost, corrupted, or hit by a targeted cyber attack.
This quote from the CIO of GCB Bank, man, it just nails it. In today's world of ransomware attacks, having a system that can recover your data in real time isn't just a neat technical feature. It is a core business strategy. It's what gives you the power to just say no to the hackers, because you know you can get your data back, no ransom required.
And a huge part of that security comes down to how you manage your cryptographic keys. These are literally the digital keys that lock and unlock all of your precious data. You can't just leave them lying around on a server somewhere. The absolute core principles are to keep them under lock and key. Use strong, random keys, store them in specialized, tamper-proof hardware, and change them out regularly. It's basically like changing the locks on a digital Fort Knox.
So we've covered the core principles, right? But when it's time to actually build one of these things, the architects face a really big choice. See, there are different philosophies on how to build a global database, and every single one comes with its own set of trade-offs.
And this brings us to an absolutely crucial point. There is no such thing as the single best database. It just doesn't exist. The right choice for you depends entirely on the trade-offs you are willing to make. What do you care about more? The flexibility to run on any cloud you want, or squeezing every last drop of performance out of the system?
And this slide gives you a perfect example of those exact trade-offs. On one side, you've got a database like CockroachDB. It's built for ultimate flexibility. Run it on AWS, Azure, Google Cloud, even your own servers. It doesn't care. On the other side, you have Google Spanner. It is built for raw, blistering performance, but it's totally tied to Google's cloud and needs specialized Google hardware, we're talking atomic clocks, to work its magic. So the real choice here is between portable freedom and deeply integrated power.
So let's just recap the toolkit for taming this global data beast. It all starts with intelligent distribution using sharding. It's made rock solid with high availability by mirroring data across multiple regions. And the whole thing is protected by robust security, from managing your keys to being able to recover in an instant. These are the pillars of any modern, world-class data architecture.
And that brings me to one last thought I want to leave you with. We've just walked through how incredibly complex this all is for human architects to manage. So as these systems get even more impossibly complex, are we eventually going to hand the keys over to an AI? Can you imagine an AI that analyzes global traffic, compliance laws, and security threats in real time to design and manage the perfect database on the fly? It's a pretty wild question for the future.